This is a tip and spin, and it's an incredibly weird and unique contraption that we have here at the Museum of Science. Now, it looks absolutely terrifying, and it is, because the top piece that I'm on isn't actually attached to the bottom. There's a red pin below where my feet are, and this red pin isn't screwed in, it's not hooked in, it's just balancing in a silver divot, kind of like a mortar and pestle would be. If I was big enough and strong enough, I could just lift it up, kind of like this. But I know I'm safe up here because of physics. There's a ton of weight at the bottom of the tip and spin, and because there's so much weight, it moves the object's center of mass way below the balancing point, the point at which the red pin is balancing. So because the center of mass is so low, I can go from side to side up here, front and back, and I'm completely fine.
This device we call the pencil accelerator. It's gonna end up going about 300 miles per hour at this end. So we're gonna start with an ordinary pencil, and I'm gonna sharpen it. All right, and we're gonna put it right here. Maynard, at the other end, we've got a piece of wood.
Piece of wood, real wood right here.
And this pencil, in a moment, we're gonna attach to a tank. The tank is compressed gas. So we're gonna push it. It's gonna go from 0 miles per hour along this red tube, which is about 10 feet. It's gonna go faster and faster and faster. What's gonna happen to the pencil?
3, 2, 1. Wow. Now, what action do we have going on here, Janine?
So we had a small mass accelerated to a huge amount, and we got a giant force out of it. So force equals mass times acceleration. That's what we just witnessed here.
Don't try this at home. What we have here are over 1,000 real pointed nails sticking straight up. My force is pushing this balloon against one of those teeny tiny nails, and the pressure is so high that the balloon pops. But when the force is spread out over many more nails, the balloon does not pop. Each of these nails is only holding up a tiny fraction of Janine's weight, so she can barely feel them. Right, Janine?
Yes.
This is because of pressure. We can even add more weight and more force, and Janine is still perfectly safe because all of this extra force gets spread out over every single nail, and Janine is safe the entire time.